Hello and welcome to this technical debrief brought to you by the 1895 podcast. I'm Tom.
And I'm Rob.
And those first two have gone down very well, haven't they, Rob?
So I've really enjoyed these bite-sized technical episodes, Tom. I think it's great to take a bite and to kind of dive in on some of these technology platforms. Couldn't have started with a better topic in terms of CO2, carbon capture, and all about that decarbonisation link in many respects.
Yeah, and let's delve into that just a little bit more on the CO2 side of things, as we'll be discussing amine degradation products and MOFs for CO2 capture. Well, I say we won't be discussing it at all.
No, we'll be leaving that to Steve and Manohara.
Hey, this is Steve, and today I'm in Paris at the Gas Analysis 2026 event. And I've got the pleasure of being able to talk with Manohara from the NPL in Teddington, London.
At this point of time, amine-based capture technologies are mature enough and they're perfectly fine. We know their chemistry from last 30, 40 years. That is nothing new. What's new there is they have a risk of degrading during continuous cycling over a number of years. So they do emit hazardous degradation products nitrosamines, amines. So they which we don't have accurate estimation or accurate measurements of those things. So if you don't know, it's very difficult to regulate around these capture plants. So it's fine, but they work perfectly. They probably do what they want to do, but we don't know enough about degradation products. Yeah. So without which it will be difficult for people who regulate environment and having confidence in those technologies to go ahead and implement it at a industrial scale. So that's why because then we looked at what is lacking. So there is no accurate metrology to assess this material under the conditions which are probably employed. So that's where we use our metrology, gas metrology infrastructure to test these materials under the conditions they're meant to be using, and then see what comes out of it and develop materials for it, reference materials, and also reference methods, analytical methods, use those and then accurately assess these materials. That information would be useful for our regulators. That information will be useful for our governments to frame policies around how to monitor these CO2 capture plants based on amines. And also it will give you opportunity for people who develop these capture materials to improvise, come up with better solutions in the future. Without having this data, makes them stay at where they are now. So that's one point. And then your question about whether we did test solid based materials. Of course, we have extending our work from calcium oxide. We started with the calcium oxide, which is a benchmark material because we know how it works, how it performs. So we developed the methods, and then based on that, we're looking at advanced materials like MOFs, zeolites, any advanced material in the system, in the capture area. So test them under the conditions that they need to be tested, and then try to understand how they perform under the conditions using our reference materials, because we know what the gas composition is accurately. Then we feed the system with gas these reference materials, and then we also measure outside of what coming out of the capture unit. So you can do the mass balance and see how much they capture, how much they emit, and if there is any degradation products during the cycling process they come out, then we can assess them in the same way as we assessing amines. Then again, that will give you insights into chemistry of these materials, and also there is opportunity for developing next generation capture materials.
And why would you mentioned something about let's say the environmental or health concerns with amine emissions, but if I look at adsorbents such as zeolites and MOFs, do they bring any benefits apart from potentially fewer toxic emissions? I mean, is it going to be more energy efficient if I can capture CO2 with these solid adsorbents? What kind of other benefits might they bring?
On paper, from the just purely chemistry perspective, solid-based solvents have versatility. They can be tuned. They have a less energy consumption. The chemistry can be optimized as opposed to the liquids, and also they're easy to handle. They need a less space. everything is perfectly fine, but like we do have a very less experimental data at a larger scale, how they really perform when you put them for like a test. So that aspect needs to be tested. So without which I think we are not in a position, at least like an industry not in a position to make a massive investment and upscale these capture materials to industrial scale CO2 capture. There is a promise, but there is a lot of work needs to be done. And that work has to be begin with developing a metrology needed to assess these materials, because as I said, there is a data out, but the data not necessarily accurate and traceable enough. So without having that infrastructure, you can't make a case for these materials just based on what you see in the public domain. So that's what we are doing. We're trying to develop this platform so that you can test all these promising novel materials for capture CO2 capture, and then that data would be kind of useful information for people who wants to make a research on these materials to come up with a better materials, and also it will be useful for people to make a decision on either investment or policy based around these solid CO2 capture materials.
Fantastic, Manohara.